Alright, so in this video, what we want to do is to solve recurrence relation subject to some initial conditions where the characteristic equation has a repeated root. So what we have here is a sub n is equal to 6 times the previous term minus 9 times the term previous to that, subject to a not be negative 2, a1 is 5. So our first thing we want to note is that when we take a look at our characteristic equation, we got r squared minus 6r plus 9. Well, we want to set that equal to 0. And what we note is that the left-hand side is factorable into r minus 3 squared. And so that gives us 3 as a repeated root. And therefore, a sub n is going to be of the form c 3 to the n plus d n 3 to the n. Now, my right hand side here is a solution to every single possible sequence that satisfies this recursion here. But not every choice of C and D gives us those two initial conditions. In order to see that, we need to evaluate. So what we note is that a sub 0, which is negative 2, is also equal to c 3 to the 0 plus d0 3 to the 0. So in this case, just c. And a sub 1, which is 5, is just c 3 to the first plus d1 3 to the 1, or 3c plus 3d. Now, the first equation here just tells me right away that c is negative 2. Now, I could REF all this, but I think it's actually less work just to work this out. We note that 5 then is equal to minus 6 plus 3d. 3d is 11, d is 11 thirds. That's my other coefficient. So this whole thing is minus 2 times 3 to the n plus 11 thirds and 3 to the n. So that is the closed form for a recursion which satisfies this recursive relation along with these initial conditions. Now, to check out the first 100 terms or so. So we let n be 100, just like before. My closed form is allegedly minus 2 times 3 to the n plus 11 thirds times n times 3 to the n. And what I want to set as my initial condition is minus 2 for the 0th term, 5 for the second term, and let's run that. And what we see is, sure enough, for the first 100 terms, those all align perfectly. So that seems like we're on the right track here. All right. Thank you very much. As usual, please ask me any questions that you may have. Thank you.